Welcome to another deep dive into the cosmos. You might think you know the dangers of space, no air, extreme temperatures, but today we're going beyond the obvious to explore the real threats that astronauts and future space travelers face. Prepare to see space in a whole new, more perilous light. One of the most significant and growing dangers is space debris or space junk. Decades of space exploration have left behind millions of pieces of discarded satellites, rocket parts, and even tools orbiting Earth at incredible speeds. The largest pieces are tracked, but the smaller ones, anything less than 10 centimeters, are almost impossible to monitor. Scientists estimate there are more than 500,000 pieces of this tiny, high-speed shrapnel, all moving at speeds of up to 17,500 miles per hour. A collision with even a small piece of debris can create a new, catastrophic explosion, severely damaging or destroying a spacecraft. Imagine a tiny paint chip hitting your vehicle's windshield at 7 times the speed of a bullet. That's the reality of the space junk problem, and it's getting worse, creating a cascading effect known as the Kessler syndrome, where one collision creates more debris leading to more collisions and potentially making low Earth orbit unusable for future generations. Beyond our planet's orbit lies the harsh reality of cosmic radiation. Earth's magnetic field and atmosphere protect us from most of the harmful charged particles from the sun and cosmic rays from distant galaxies. But outside this protective shield, astronauts are constantly bombarded with radiation that can significantly increase their risk of cancer, cataracts, and other long-term health problems. A powerful solar flare could unleash a deadly burst of radiation in minutes, and without proper shielding, the effects would be catastrophic. The radiation consists of two main types: particles from solar events and high-energy galactic cosmic rays from supernova and black holes. While solar events are somewhat predictable, galactic cosmic rays are a constant and unavoidable threat. Long-duration missions like those to Mars would expose astronauts to a lifetime's worth of radiation dose in just a few years, potentially causing irreversible damage to their DNA. Another often underestimated danger is the psychological toll of space travel. Imagine being confined to a small spacecraft for months or even years, millions of miles away from home. The isolation is profound. There are no windows you can open, no one else to talk to besides your crewmates, and no escape. Sensory deprivation is also a major factor. The lack of natural light, the constant hum of machinery, and the absence of fresh air can affect an astronaut's mental state. The constant awareness of being in a hostile, dangerous environment, with the fate of the mission resting on every decision, creates immense stress and anxiety. This mental strain can lead to cognitive decline, difficulty making decisions, and interpersonal conflict among the crew, all of which are a serious threat to mission success. Microgravity, while seemingly freeing and fun, also presents numerous dangers to the human body. Without the constant pull of gravity, astronauts' bones lose density at a rapid rate, up to 1% per month. Their muscles begin to atrophy, especially in the back and legs, which are no longer needed to support their weight. The body's fluids shift upwards, which can cause significant swelling in the face and a puffy head, bird legs appearance. More seriously, this fluid shift can cause an increase in pressure on the brain and eyes, leading to a condition called space-associated neuroocular syndrome, SANS, which can result in long-term vision problems. The cardiovascular system also struggles to adapt, and the immune system weakens, making astronauts more susceptible to illness. A less talked about but very real threat is fire in space. On Earth, flames rise and extinguish themselves, but in microgravity, fire behaves differently. There is no convection to pull the flame upward, so it burns as a slow, spherical ball. This means fire can smolder and spread in unexpected ways, making it much harder to contain. The International Space Station has strict fire protocols for this very reason. A fire in a confined, oxygen-rich environment like a spacecraft is a nightmare scenario. Smoke detectors and fire extinguishers are essential, but even a small fire could fill the cabin with toxic smoke, forcing an immediate evacuation or leading to a rapid loss of life. Finally, let's not forget the sheer unpredictability of space itself. Unforeseen solar flares can release massive amounts of radiation in a short period. Micrometeoroid showers, while often small, can still damage sensitive equipment. And the vast, cold emptiness means that help is always a long way off in case of an emergency. Space exploration is an inherently risky endeavor. There is no rescue service in deep space, and a broken piece of equipment or a small crack in the hull can lead to disaster in minutes. Every mission is a gamble against the unknown, a test of human ingenuity and resilience against the most hostile environment imaginable.